Public perception of veganism is heavily skewed by advocacy media and streaming documentaries that mix valid concern with statistical overreach. A recurring example is the frequently cited claim that livestock production is responsible for 51% of all global greenhouse gases. The actual peer-reviewed baseline from the Food and Agricultural Organization of the United Nations tracks livestock supply chain emissions at roughly 14.5%. We do not need inflated statistics to evaluate the utility of a plant-based diet. Discarding the advocacy hype leaves us with a verifiable empirical framework built on hard probabilities, the Convergence Thesis. The formal definition of veganism seeks to exclude animal exploitation as far as is possible and practicable. It is an optimization problem operating under real-world constraints. We can analyze this optimization across three specific vectors. The first is high-leverage environmental mitigation. The second involves biological boundary conditions and conditional health outcomes. The third evaluates practical harm reduction regarding animal ethics and sentience. To test this thesis, we have to abandon ideological purity tests and look strictly at the peer-reviewed data across all three areas. Animal agriculture operates on a massive physical scale. This scale is driven by a biological mechanic called trophic inefficiency. Trophic inefficiency refers to the massive loss of energy and biomass that occurs each time you move one step up a food chain. Because of this energy loss, producing calories from an animal requires exponentially more water, land, and crop inputs than growing plant calories directly. Life cycle assessments evaluate the total environmental impacts of a product, from its creation to its end. This multi-dataset LCA chart shows meat, aquaculture, eggs, and dairy monopolize roughly 83% of global farmland. Despite taking up 83% of the land, these products yield only about 18% of the global calorie supply and just 37% of global protein. Models based on this baseline show that moving away from animal products could theoretically free up approximately 76% of food-related land use. The same models indicate an accompanying drop in food-related greenhouse gases of roughly 49%. Real-world observational data from the UK confirms these models, showing that actual vegans operate with a fraction of the land and water footprints of high meat eaters. Shifting to a plant-based food system operates as a mathematically high-leverage necessity for global climate mitigation. There is a pop culture heuristic that a vegan diet is automatically an optimal diet. In reality, the clinical outcomes are entirely conditional. We see strong short-term cardiometabolic benefits in randomized controlled trials, or RCTs. An RCT randomly assigns participants to an experimental or control group to isolate the effect. This graph shows the results from that 8-week intervention. Participants on a healthy vegan diet experienced a sharp downward trend in LDL cholesterol and fasting insulin levels compared to the omnivorous control group. However, long-term epidemiological cohort data exposes systemic vulnerabilities. Epidemiological cohort data refers to observational studies that follow large groups of people over many years to see how their habits affect their long-term health. In datasets like EPIC Oxford, we see a concerning divergent trendline. Vegans face a higher risk of total and site-specific bone fractures, particularly hip fractures. The same long-term data also tracks a second warning signal, showing potentially higher rates of hemorrhagic stroke compared to meat eaters. These failures stem from the absence of deliberate nutrient engineering, specifically inadequate intake of vitamin B12 and calcium. There is also a severe penalty for relying on ultra-processed plant foods, or UPFs. Consuming industrial formulations made mostly from extracted substances and additives carries a roughly 40% higher cardiovascular risk than eating a whole food plant diet. The medical consensus confirms a vegan diet can be adequate across all life stages, provided these specific failure modes are proactively managed. The health case for veganism is viable, but it demands strict, continuous biological engineering rather than a passive avoidance of animal products. The ethical argument for veganism relies on expected harm rather than emotional appeals. Expected harm is a probability calculation that multiplies the severity of an outcome by the likelihood it occurs. Modern legal frameworks increasingly recognize animal sentience as a policy-relevant fact. As the scientific recognition of consciousness expands, policies have updated to protect species like decapods and cephalopod mollusks. The primary driver of this expected harm calculation is the staggering scale of the industrial system. For land animals alone, the reported totals reach approximately 83 billion killed every year. This figure entirely excludes the trillions of marine animals extracted from global oceans annually. A frequent logical counterargument is that plant agriculture also causes animal deaths through harvesting machinery and pesticide use. Trophic inefficiency resolves this paradox. Because livestock require exponentially more crops for feed, consuming animals multiplies the total field crop deaths rather than reducing them. A perfectly zero-harm existence is physically impossible, making veganism the most mathematically sound harm reduction strategy available to consumers. The rigorous case for a plant-based diet does not promise perfect health or absolute moral innocence. Environmentally, it offers a verified mechanism to drastically slash land use and emissions. Ethically, it operates as a structural boycott against a system that guarantees mass expected suffering. Biologically, it requires active supplementation and a reliance on whole foods to avoid severe neurovascular and bone density trade-offs. We return to the baseline definition of veganism, acting as far as possible and practicable. This integrated, data-driven model rejects the conspiratorial narratives peddled by popular streaming documentaries. Precision and factual accuracy strengthen the argument for dietary change. The case for veganism operates as a highly rational, evidence-based response to the compounding inefficiencies of the modern world.